Well, hello, retro computing enthusiasts, electronics geeks. Mike here. Welcome back to my channel. And today I want to talk to you about a compact flash interface I have made for my NABU computer. Yes, in a previous video, I showed you how easy it was to interface the NABU to a breadboarding system. You can just plug a cable right into one of the expansion slots in the NABU, run it right out, and plug it right into your breadboard, and you can start adding hardware to your NABU. And with a little software to go along with your hardware, you can do amazing stuff. Now, I will preface this by saying I am mostly using the NABU as a development platform here. This compact flash interface really wasn't aimed at the NABU. I have a couple of other Z80 computer projects in the background. Some of you may have seen them. I'll put links in the video description and maybe in the upper right corner on occasion to some of these other projects like my Jazz 80 breadboard retro computer based on the Z80 and my S100 box over here. And I also have an old TRS-80 Model 1. So basically, I've got a lot of Z80 computers, none of which at the moment have drives attached to them, any kind of mass storage. Well, including the NABU, although with the NABU, at least RetroNet CPM is available for it. So I don't really need drives for the NABU, but it's a good development platform. It gives me everything I need to develop hardware and software for my other computer projects. So I'm using the NABU. But hey, leave a comment and let me know if you'd be interested in seeing a compact flash system, especially for the NABU, and maybe a standalone version of CPM for the NABU on the compact flash. Let me know if you'd be interested in that. If there's enough interest, I may wind up developing that in the future because I've got to get good at customizing CPM anyway for my other projects. So once I know how to customize CPM, customizing it for the NABU hardware running off of compact flash should be pretty easy. So if there's enough interest, I will likely take on that project. So let me know in the comments. I'll give you a quick overview of how the compact flash system here works, and I'll show you what I've got going so far. I don't have a real file system on here yet, or an operating system, but at least I can read and write sectors to and from the compact flash card. So let me show you what we've got here. Well, to start with, we've got the interface cable, like I said. This is just a 60 conductor interface cable that plugs right into one of the 30-pin expansion cards in the NABU. So I'm only using half the conductors in the cable, but that's fine. That's all I need. And I'm running it out and plugging it in the breadboard. Now, in the breadboard over here, in the previous video, I showed you a circuit I built on the breadboard. So most of the stuff on the breadboard here is for that previous circuit. You can just ignore pretty much all of this, all right? Because the only stuff that we need for the compact flash drive is, well, a flash drive socket, and we've got one lone IC chip here, and that's it. The rest of this is for the other circuit. So this is super simple. With the NABU doing I/O address decoding in there for the expansion slots over there, this gets to be a really simple interface. You don't need a lot else to make it work. So there are a few gotchas with working with compact flash drives, and I'll show you one right now. So when I first started this project, I made a big mistake, and I beat my head against a brick wall for a good week before I figured out what my mistake was. And my initial mistake was buying an adapter card like this. These are available everywhere, okay? They're cheap. They work great to turn a compact flash card into an IDE drive in your computer, okay? And I thought this would be a super simple method of hooking up a compact flash card to a retro computer. I could just plug the flash card in here and I could emulate an IDE interface in hardware. It's pretty simple. And well, when I got around to writing the software, I couldn't get anything to work right, or at least consistently. Sometimes I could read data from the card. Sometimes I couldn't. Sometimes I got a lot of errors out of the card when I would send it commands. Other commands would work great. It was just totally unreliable and unworkable. And it took me a while to figure out what the problem was. The problem was the way these cards are pre-wired to work with an IDE interface. You can't put the card in true ATA format, which is what you need to do to use it with a retro computer. So this would work great as an IDE drive, but it doesn't work great in true ATA format, which is what you really need. That left me with a big problem. After I figured out this wasn't going to work, I figured out what I really needed to do was wire up to all those little contacts. I'm zoomed in about as far as I can go. All those little contacts, and there's 50 of them, on the back of the CF card connector here, and wired up the way I needed it wired up so I could get it in true ATA mode. And I'm like, whew, that is some tiny, tiny soldering there. I'm not sure I want to go to that length. So I started looking around on the internet. And I found this. Somebody makes a breakout board with headers on the back that will plug right into a breadboard. And I thought, well, that's exactly what I need. I don't have to do any soldering. It's already soldered onto this breakout board. I can just plug this in the breadboard and start wiring it up, and hopefully I can get it working. So I got this from a company called Proto Advantage. Great. The shipping was fast. The price is reasonable. You know, if you want to get into this compact flash drive stuff, you probably want a connector like this. Unless you're really good at surface mount soldering lots and lots of little connections, all right? I'm not that great at it. I'm first to admit it. So you can get these from Proto Advantage. Like I said, they're not expensive. Shipping was quick and easy. So yeah, check them out. But yeah, with this, things went a whole lot smoother. So here you can see one of those Proto Advantage cards in the breadboard with a compact flash card in it. And just basically, you've got to wire up the 8 data lines, 3 address lines, read, write, a chip enable line, and you've got to set a lot of other lines high or low by grounding them or moving them to VCC to, or binding them to VCC to get everything in the mode you want so it works. There's an activity signal that comes off that will light an LED whenever the drive is active. And basically that's it. It's super simple. Like I said, none of this hardware over here has anything to do with the compact flash interface. I'll give you a look at the schematic for this and show you how simple it is to wire up. All right, let's take a quick look at the schematic here. There's really not much to it. Over here I am bringing in the 30 lines from the first expansion connector on the NABU. That's the one on the farthest left, looking at it from the front of the machine. And it has a CSO line on it that decodes IO address and IO address range from C0 to CF. So 16 IO ports, all right? This project only uses the lower 8 of them, so C0 through C7 are all we are using. Not doing any IO decoding on this board, don't need to, really. So all we're doing really is mostly just moving lines from the NABU directly to the CF card. We've got the data lines, got A0 through A2 address lines, reset, got the CSO signal. We are doing a little processing on the IO write and IO read lines, which are coming in over here. I'm running them through some OR gates here and gating them with the IO request signal so that we don't interfere with memory requests. They were only going to read and write to the CF card with IO requests. Also, some of the literature I've seen says that the IO write and IO read lines need to lag behind the select lines a little bit for timing purposes. I've seen some people not bother with this and just wire the read and write lines directly from their systems, but you know, from the literature I've seen, they're supposed to these are supposed to lag behind select. So anyway, that's the way I did it. So we've got a little bit of a propagation delay through the OR gates that's going to lag the signals a little bit. Anyway, it works. Over here at the CF card, we're going to ground a whole lot of lines that we don't need. Some of them are important, like the one to select true ATA mode. So yeah, grounding these, we're going to tie some lines to 5 volts through resistors, pull them up. We're going to have a whole lot of lines that just aren't connected to anything. We're just going to leave them disconnected. And we've got one line here, the activity line, we're going to use to light up an activity LED when the drive is in use. And that's pretty much all there is to it. There's a couple of decoupling capacitors, one for this quad OR IC, 74LS32 IC, and I just put one on the power rail for the CF connector just to try and smooth out any glitches in the power. And that's about it. The spare 2 OR gates in the 74LS32, I just have their inputs grounded so they don't just hammer back and forth between high and low with noise, which is bad. So that's about it. We're pulling plus 5 volts in ground from the NABU expansion socket, so it's powering this whole thing. And super simple, super easy. There you go. There's the entire hardware of the project. The rest of it's just software. So another problem I had with this board before I switched to this board was that I could only manage to talk to some compact flash drives. Others just didn't work. Since I switched to this board, every single compact flash drive I have tried in the board up here works just fine, just the way it's supposed to. All right, and I have quite a variety of compact flash cards here from different, I don't know where some of them came from. Over on my main channel, I scrap out old electronics. If I get like an old Cisco switch or something, a lot of times they'll have a compact flash card in them for configuration or for storing log data. And I'll always save the compact flash drive, just throw it in a drawer and keep it. So I've got a bunch of them in different sizes. I actually bought this specifically for use in this project. And it didn't work at first, but now with this connector here, it works just fine. And some of these others I think I got from various switches and other equipment too, switches, routers that had compact flash cards in them. I just pull them out and save them. Every single one of these works. The one I'm using up here right now is a Cisco 128 megabyte unit. Not the biggest compact flash card on earth by far, 128 megabytes, but for a CPM system, that is like a lot of space. That is like a bottomless pit of space for the average CPM system. So that's plenty of space. So let me reposition the camera and I'll show you this thing in operation. All right. Okay, so I've repositioned the camera and we are pointed at the monitor and we are running 0.9.06 version of my NABU standalone project monitor here. So basically what I've done is I've pulled the original ROMs out of the NABU and I have replaced them with my own custom monitor. And it's what I do, okay? I can't resist hacking, all right? I get a computer. First thing I do is I start messing around with it. First thing I did with the NABU was pull the original ROMs out and start hacking together my own software for it. So I've got a whole series on doing that, and I will put a link to the NABU playlist in the upper right. You can check that out if you like. It goes from initial unboxing, unpacking of the NABU up to basically this point where I've got all this custom software running on it. Plus, if I want to, I can run the original NABU software. I have 32K EEPROM in the machine, and I have bank switching available where I can see any of the 4 8K banks in that ROM, and one of those 4 8K banks contains the original NABU firmware, so I can run that too. I also have Microsoft Basic in ROM, and it's just a beautiful thing. And some of those other NABU videos cover all that stuff. So let's take a look at what I've got here. So I've written a couple of functions that read and write sectors to the compact flash drive. So if we want to read a sector from the compact flash drive, I've burned them into ROM, but I don't have them on the menu up here, but I know where they are in memory. So I can call them up. Say we want to read a sector. So we would go to address 11A0. And it's going to ask me it says CF card read test. Okay, enter sector to read. Now I am only using the first 65,000 sectors in the CF card. Larger density cards have millions of sectors, like this 8 gigabyte drive here. So I'm only using the lower 65,000 sectors on these drives. I can access, a lot more, but for now we're just going with the lower 65,000. I mean, that gives me over 33 megabytes of space to play with just by using the lower 65,000 sectors on the drive. So that's plenty to start with. I can always finesse this later. So it's asking me for a sector to read, so I'll put in a word, basically a 16-bit word. Let's read the 0th sector on the card, because that's always interesting. That's where the boot sector is. So let's read 0000. Now it's asking me where to put it in RAM. So it will read out that sector and put it in a RAM buffer. We'll use 9,000 hex. Boom, just that quick. Let me do that again and show you the activity light on the board down here. Yeah, that's quick. Just a fraction of a second to read those 512 bytes out of that sector. So now we can take a look at the sector, and this is a good opportunity to show off my new hex dump program. I was not happy with my old hex dump program, so I completely rewrote it. So we will dump 9,000 hex. And what we can see here, yeah, this is the boot sector. This is what's on the boot sector of that compact flash drive. Down here, bootable, partition, table, invalid, partition. Yeah, look at some more of it. Table is valid or damaged, bootable, partition. Yeah, it's basically, you see this on the partition table or sector 0 of every drive. That's there. And so we've got 512 bytes of data. The rest of it looks like zeros until you get to the end down here. Well, there's a little bit more stuff there. This is basically telling you the size of the drive. Looks like we've got one drive on the partition table. And then partition tables always end with 55 AA. So there we are. So that's the 512 bytes of data on the sector 0 of that compact flash card. So let's read another sector and see what's in it. Let's go again, go to 11A0. Let's just pick a number out of thin air. Let's go with 1, 2, 3, 4. All right. RAM buffer, we'll go to 9,000 again. Boom, done. Just that quick. So let's dump 9,000 again. And we just got some random data that was on that drive. I have not, erased these drives or reformatted them, so whatever was on them is there. So we can read out the rest of it there. And then we get down here to the alternating FFs and 00s. That's just random junk in the RAM. So yeah, get over here to 1FF. That's 512 bytes of data. So, all right. So the read is working perfectly well. So I have another little program on here that will write a pattern out into RAM, into a buffer in RAM, 512 bytes, so that we can write that pattern out to the card and make sure that we are getting it on the card and it's all working good. So let me go to that program, go to 6000. Okay, so it's done. So what it's done is it's filled a 512 byte buffer in RAM with a pattern, and we can go look at that. We'll dump 7000. So what we've done is we've filled 512 bytes in RAM with just the pattern AA over and over and over again. Okay, so we got 512 bytes of AA. So now we can write a sector. So write a sector is at 12A5. So it's asking me the sector to write. So let's make up a number here, any number. Let's see, we did 1, 2, 3, 4 before. Let's do 4, 3, 2, 1. Okay. RAM buffer start, well, that was at 7000 where my field of AAs is. So we'll put that in there. Boom, writing is as quick as reading. So now let's read back the contents of sector 4321 and see what we got. So we got to go to the read sector again, which is 11A0. Sector to read 4321. Put it in 9000. Okay, now let's dump 9000. Look at that, a field of AAs. So we can read and write 512 byte sectors to the compact flash drive. And I don't know if I mentioned this earlier, probably not. That is the standard size of the sector on compact flash drives, 512 bytes. It's quite a bit bigger than what CPM expects. CPM operates on 128 byte sectors, but there are ways around that problem. So that will be something I work on in the future to make that work. But yeah, we've got a field of AAs here on the compact flash drive now, so that works just great. So now that we can read sectors from the drive and write sectors to the drive, we have the rudiments here of a disk operating system. It's crude, it needs a lot of work, but we've got the rudiments of it. From here on out, it's just software. The hardware's working great, okay? You know, I could whip together something really quick and dirty that would just write the entire contents of the RAM of the NABU computer here out to the CF drive and give, you know, that RAM image a name in sort of a simple directory. And what I could do is whenever I wanted to read that image back in, I could read that image back in and the computer would be in the exact same state it was when I wrote it all out. That's the way a lot of early like tape and disk systems worked, similar to that, where they would just, you know, sort of write the memory out and give it a name in a directory. I could say I loaded Star Trek in here and was playing a game of Star Trek in here. And I wanted to save that because loading Star Trek takes a long time. It's a big basic game, and loading it in here and running it takes a long time. And if I just wanted to be able to load it instantly again off the compact flash drive, once I had it up and running on here, I could just save the entire contents of the RAM memory off as basically one file. And then if I wanted to run Star Trek again, I could load that file back in and the computer would be in the exact same state it was in before. And I could do that, you know, however many times. I mean, you know, we've got, what, 56K of free RAM in this system. So 56K doesn't take up that many 512 byte sectors. So I could do that a lot of times to a CF card, even a low resolution CF card like this one, even only using the lower 65,000 sectors, I could do that a whole lot of times. So yeah, so we've got the rudiments of a basic operating system here. As operating systems got more complex and allowed more things in the future, we came up with like CPM and later DOS and Windows and Linux and whatnot, Unix, you know, all their different file systems They're very much more complicated than this basic thing I'm talking about. But I could probably in an afternoon whip up something really basic like that. But my goal down the road is to get CPM running on some of my other retro computers, like my Jazz 80 computer, my S100 box over there, maybe even the Tandy Model 1. And I have some other computers laying around. I've got an 8085 board computer. I could maybe get it running on that too. So that's my goal in the future. Not necessarily with the NABU. Like I said, I'm just using the NABU really as a development system right now because it's just so easily hackable. I love how easily hackable this computer is. So it's just allowing me to develop stuff. And the code base I'm developing can just be translated right over into these other computers. I just have to refactor it a little bit, here and there, and or reassemble it, and it should work just great on these other computers. So, that's why I'm doing it on the NABU. But like I said, leave me a comment and let me know if you want to see me develop a standalone CPM for the NABU that operates out of a compact flash card, because it probably would not be that too difficult to do once I sort of cut my teeth on doing it for my other systems. So yeah, leave a comment. Let me know. And I would like to acknowledge a few people out there. Don Stewart over at CPUville, Grant Searle, and Jeff Tranter. These are folks who've all done this with their retro computers, got CF cards working with them. And my code is kind of an amalgam of some of what they're doing along with my own hackery mixed in. Um, so thank you guys for your assistance in getting this working. Like I said, I beat my head against a brick wall for quite a while before the light came on, and it's reading these guys' publicly available code that helped me understand where I was going wrong. So these are great guys. I'll put links to their websites, blogs, whatever, in the description of this video down below. Check them out too. But if there's enough interest, I will release the code I have so far, although I would recommend waiting until I make it a little bit more mature. Like I said, we only got the rudiments of an operating system here. There's a long way to go. We can read sectors, we can write sectors, but there's a long way to go. So I hope you found this episode of NABU Hacking interesting, educational, informative, inspirational, whatever. Give it a like, give it a thumbs up, and subscribe to see my future videos. There'll be more on the NABU. There'll be more on the Jazz 80. There'll be more on the S100 box, etc., etc., etc. I have other plans in the future, too, that you don't even know about yet. So they'll come as a surprise. So subscribe to see those surprise videos. And I'll see you in the next video. Thanks a lot for watching this one. Bye.